coming up on Sleep, Eat, Perform, Repeat.
So in other words, you won't quite have a quick route to something like cancer or, say, Alzheimer's or Parkinson's. But the truth is, the more people you put behind something, the more money you invest, the bigger the chance is going to be to make a difference and make progress. So again, I hope, and it's happening actually, greater investment now in biomedical research on the back of the COVID success should accelerate discovery and new treatments for these other diseases as well, we hope. But it won't be quite as straightforward as sticking a bit of a virus into someone and hoping it works as a vaccine, if you know what I mean. These are devastating diseases. They will increase in incidence as our population ages, and we all know people with these diseases. So we need to really put our shoulder to the wheel as soon as we can, because these are becoming so serious. I am Professor Luke O'Neill, and I'm very happy today to talk about my new book, What Makes Us Human, and it's all about what makes us interesting as a species. It's aimed at curious kids, and I'm very happy to take part in this podcast of Sleep, Eat, Perform, Repeat.
Welcome to Sleep, Eat, Perform, Repeat with your hosts, David Clancy and Kieran Dunn. This is a podcast about high performance. What we are striving to achieve is to figure out what makes high-performing individuals tick, why they do what they do, and why they are successful. Enjoy a journey of stories, lessons, and learnings.
Today we spoke with Professor Luke O'Neill, Professor of Biochemistry in the School of Biochemistry and Immunology at Trinity College, Dublin. Professor Luke O'Neill is a world-renowned scientist who has a passion to engage with the general public on scientific topics. He is amazing at using simple and clear language to explain complex things. Professor Luke O'Neill has been recognised in his effort to popularise science and in raising the profile and awareness around the value of science to human progress. A regular presence on national radio and TV, such as News Talk and RTE, Luke has also published several books, including Keep Calm and Trust the Science, An Extraordinary Year in the Life of an Immunologist, his diary covering the COVID-19 pandemic, Never Mind the Bollocks, Here's the Science, and most recently, What Makes Us Human, a scientist's guide to our amazing existence, with Guild Publishers. We spoke about energy, how he manages all his projects, dinner table conversations at home, but also his love and passion for music. We unpacked developments in neurodegenerative illness and cancer research, and what learnings we've taken from the pandemic in that regard. Luke talks about hormones, his breakfast routine, but also his managerial role in the lab. Professor Luke O'Neill is a highly skilled communicator, loves challenges, the challenges that science gives him, and has a really wonderful zest and vigour. Enjoy this one, because we certainly did. Professor Luke O'Neill, welcome to the show. We'd like to start with, we're always curious about breakfast of champions, Kieran, but what do scientists have for breakfast?
Oh, that's a personal question. I couldn't answer that. Well, first of all, thanks for having me on, guys. Delighted to chat about the book. I'm a great man for plugging my own book, as you would appreciate. I'm not a big man for breakfasts, interestingly. I might have a cup of coffee and a nice piece of toast with a bit of marmalade. That normally does me, All the food groups are kind of in the mix there somewhere. Now, I've got a circadian rhythm, I think, that makes me hungry in the evening. So I have a big dinner every night. But I'm not a huge man for breakfast, I must admit.
Building into the coffee, do you take into account the adenosine build-up? Do you take it 90 minutes?
Oh, well done. Yeah. Absolutely. You have to antagonize the adenosine. That's the function of the caffeine, which actually is a great example of science in action for me there, that we figured out why coffee makes us alert. Isn't it great? Stop this adenosine molecule, which makes us sleepy. So it's pretty simple. Yeah, so I'm very conscious of the adenosine levels in the morning. So I make sure I need a cup of coffee to get me going, basically, as well.
What else can those curious scientists of the world do in the morning to, maybe if they haven't slept well or they're a bit stressed because of exams, what can they do in the morning to get themselves going?
Oh, that's another good question. I suppose, in my case, have a good hot shower. I love that. Or a cold shower, if you prefer. Either way, that gets me going. And your mind then begins to think about the day ahead, and you try to focus on what's in front of you, kind of thing. The second thing I always advocate, I'm a great fan of the to-do list.
Oh, yeah.
That makes you feel you're in control, and that decreases stress in a way. And you can't beat the little rush you get when you tick off. Like this morning, I'll tick off our interview, the little rush of endorphins, following our chat. So in the morning, I'll always think, what am I doing today? I've got 3 or 4 important tasks, and I focus on those, and then off I go. And then a cup of coffee up and running. They're the things I usually do anyway.
Yeah, I disagree with you when you say the shower. The only thing I'm thinking of when it's cold is get me out of here, quick.
Yes, well, that's like it. Well, some love cold water. It's a strange one. And as you both would well appreciate, jumping into the sea, very beneficial. I'm the same as you. I can't stand the cold water. I much prefer a warm, a hot shower.
Yeah, and we're two physios here, and we're having a lot of exposure at the moment to people saying, "What about the sauna? Should we get into the sauna for recovery during the week? Is that something to consider?"
Yeah.
So the whole hot cold thing, I think, is really interesting,
isn't it? Yeah, it is.
Yeah, it's great to have the conversation around it, actually. Recently, it's much more been brought to the fore, but I've managed to get up to 75 seconds and in 5-second intervals for the cold shower. Man. That is it. I'm max now. I think I've maxed out.
And is it agony, Kieran?
Agony, absolutely.
Yeah. But then you get the endorphins after, you see. No pain, no gain territory.
There you go.
I think the cold shower or the cold swim is a shortcut to an endorphin rush. That's the way to think because of the pain you're going.
So we'd love to ask the question: is you're a busy man, right? To say the least. You're on the radio, news talk. My wife listens to you. My mother listens to you. You're on the late. You're speaking to us. How do you manage your energy over a week, and how do you, keep yourself going with all these pieces where you're having to give a lot to different people?
Well, first and foremost, I would choose things that you want to do. Let's put it that way. If it was a chore, I couldn't do it. Same with the travel. I've just come back from a big tour, actually, of various countries from congresses in immunology. Now, if I was getting on a plane and not wanting to go there, that'd be a misery. You see, schlepping over to America and back off. I want to go. I want to go to the conference. I want to meet people and talk. So first and foremost, in my sort of professional life, I try to make sure I do things I really want to do, and that makes them easier then. And you need less energy to do them because you really want to do them. That's the first thing I'd say. The second is I've kind of got 4 parts to my professional life, and they're like 4 separate buckets, and I like all 4. And I make sure I keep all 4 going, and some dominate over others. Number 1 by far is my lab, just behind me here. That has precedence over everything else. I've got a big research team working on inflammatory diseases, and that's a big goal for years for me. So that's number 1. Number 2 would be if we want to try to make a new medicine, which is our dream. That means working with companies, and I do a lot of work with companies because drug companies are the place to make the medicines, and I've founded a couple myself. That'll be the second thing. The third one is the communication thing, and I began doing that 10, 15 years ago now. It's simply because I enjoyed it. That's just got a bit worse, if that's the right word. For the COVID or whateve you, and the books and all that kind of thing. So I like doing that. And then the fourth one would be the teaching, because obviously I'm an academic, so got to teach the students as well. So I'm quite organized. Is that the answer, David?
I think it is a good answer.
Yeah.
Getting all the Bunsen burners going at all the time and managing which one.
You got to keep the Bunsen. If the Bunsen burners are turned off, I'm very unhappy. Let's put it that way. Mission 1 is to be a scientist. My job is to be a scientist, you see, and that means doing research.
You recently said about the book that you're trying to inspire young people to become scientists. What's the landscape for scientists at the moment? Are we needing more and more applications in terms of CEO, in terms of college? Or is it a competitive market? What's going on at the moment?
Yeah, I believe so. And there's an uptick in people applying to do, say, immunology, for instance, and for obvious reasons, because it's in the media. It's a bit like forensics is always popular when there's a forensic show on telly. More people
CSI.
apply. Yeah, that kind of thing. Yeah. So I think we are seeing that uptick in people wanting to do science. And it's not just immunology; it's like climate. There's all these big things that confront us at the moment. All these problems that we're facing. Climate change being a big one. Another good example, mental health. There's a lot of people doing neuroscience now, you see. So I think what happens is young people want a challenge and they want to feel they're doing something meaningful, And what could be more meaningful than trying to solve climate change or solve a mental health issue, whatever it might be? And COVID gave us the evidence that science got behind that massively and delivered with the vaccine. So the young people respond to that. But you got to keep telling them, we need you. Yeah. Because there's many demands on them, isn't there? And there's many stresses and anxieties. And the message in the book is, the last page captures that, there's all these challenges. We need you to become scientists if you want. I mean, obviously it's an optional thing, but because I'm a scientist myself, I'm a bit like a Baptist minister in the pulpit in a way. Come and join us. And then maybe some will. Because the trouble is, that can put people off as well. Too much proselytizing can be a negative. So there's a balancing act there. But one reason I wrote the book was to encourage, just to first of all inform young people about how great science is. That's the first mission. And then the second is maybe they might think about becoming scientists, really. So they're the two main things that this book is trying to achieve. Really.
With the book and with those Bunsen burners, science, we're always trying to answer questions or come up with better questions, maybe even that. What are the questions that are really sparking you at the moment that maybe are going on behind you in the lab?
Yeah, well, my lab, we're an immunology lab. So what we work on is the immune system. And as you both know, the main job of the immune system is to fight infection. Clearly, it evolved to fight the bacteria and the viruses and the parasites. And it's a marvelously effective at that. Otherwise, our species would have been wiped out by these pathogens over the years. And we learned a huge amount about that. But equally importantly, it goes wrong in a whole range of diseases. And as you both know, as physios, inflammatory conditions like osteoarthritis, rheumatoid, you have IBD, MS, all of those are immune mediated, and we don't know why. So some of the questions that is uppermost in our minds is what's causing those diseases? And in my life, I've tracked it back more and more to the source in a way, So for example, we work on a thing called NLRP3, a terrible mouthful, but that is the initiator of much of the inflammatory process. And then we found drugs to block NLRP3, and they work in models of MS and Parkinson's and Alzheimer's. So really my lab is trying to come up with a deeper understanding of what goes wrong in the body during these diseases, and then maybe design drugs and therapeutics to stop it. Now of course, the other big area to mention is cancer, because, and again, I guess you both would know the great triumph of cancer in the last 20 years is to wake the immune system up to kill the tumor. These checkpoint inhibitors, I think called CAR T, this T cell therapy, they're massive advances. Now they aren't curing it yet, but they're a huge advance on what was there before. So a big question many immunologists ask is, can we get the immune system to kill a tumor? And again, lots of labs are pursuing those. So within immunology, those are some of the key things that we're interested in.
About the immune system, and of course we can read and understand a little bit more about it. Just as a sharing, I have a young girl who currently is struggling with infection, right? And she's in Temple Street, and so we're understanding infection and building up her immune system. And why did she get that? What is it about how we could have made it a bit more resilient? What can we do as humans, as young kids, as adults, maybe to help understand and do a little bit more to strengthen the immune system?
Well, we do know a lot about it. The good news is, when I began as an immunologist, it was 30 years ago, Now, our knowledge then was a tenth of what it is now, for obvious reasons. All those years of work with many tens of thousands of immunologists discovering stuff, So we do understand a lot more. And in that particular, there's often a genetic basis for these things, because we're all different, obviously, as a species. Some have a strong immune system, some have a weak one. Some have immune genes out of control, and that can drive disease. Some have immunodeficiencies, you see. So that's often in the background. But equally, the environment is extremely important. And we can do things to help our immune systems. And again, lots of research. Stress is a massive negative. And things like cortisol suppress the immune response, you see. Exercise is massively beneficial. There's a number of reasons for that, David. One is just the blood flow. It stimulates the immune system. So as your blood flows, all the leukocytes in your circulation are surfing the wave of the blood. There's a good analogy for it. And they're kind of waking up. So exercise is great. Nutrition, really important. Obviously, people who are malnourished, you're at a high risk of infection. That's the third one. And then the fourth one is sleep. And again, loads of studies showing a bad night's sleep can drop your immune system by a third the next day, for instance. Now, if you're unlucky enough to be exposed to a virus after a bad night's sleep, maybe that's the day you get infected because you didn't have a good night's sleep. So again, we know a lot about the mechanisms in there, which is great, because I like that. And in fact, during the pandemic, before the vaccines came along, I was saying to people, you're not powerless here. There are things you can do to help your own body fight the infection. And those are the four main areas that we advise people to follow, really.
You touched on something earlier about how the world came together to fight coronavirus. We, very quickly got vaccines together, and we kind of, through a necessity, obviously survival, our most vital need, made this the primary goal for a lot of countries, for a lot of individuals, a lot of scientists.
Yeah.
If we were able to shift perspective on other diseases like cancer or anything like that, do you think we could achieve similar outcomes in maybe not as quick a time?
Classic Irish, I do and I don't. So, the vaccines turned out to be somewhat straightforward in retrospect. Now, we got lucky with them, it must be said. So that RNA technology, as you know, the RNA is used by Pfizer and Moderna. That hadn't really been used before for vaccines for infectious diseases. It had been used for cancer, interestingly. And they gave it a go, and it worked fantastically. So we were lucky. Now, if that hadn't worked, we still would have got vaccines using the more traditional vaccines. Like, for example, Novavax has what's called a subunit vaccine. That's the protein. And that's like an old-fashioned, and that works well, Neva have an old-fashioned inactivated virus. But the truth is, the RNA came along, worked brilliantly. So we got a bit lucky there in a way, And then they turned out to be the first generation vaccines, I guess. Now, meanwhile, these other ones are there. they're almost as good, you know. And of course, what I like to quote now is, and the statistics are getting even more remarkable, the data that's coming. And remember, if you're a scientist, you're driven only by data. If you haven't got the data, shut up, right? So the vaccines saved 20 million lives in 1 year. That's like stopping a war, you know. The 20 million people didn't die because of these vaccines, so they work brilliantly. Now, if you turn to other diseases, the trouble is they're more complicated. You know, so in other words, you won't quite have a quick route to something like cancer or, say, Alzheimer's or Parkinson's. But the truth is, the more people you put behind something, the more money you invest, the bigger the chance is going to be to make a difference and make progress. So again, I hope, and it's happening actually, greater investment now in biomedical research on the back of the COVID success should accelerate discovery and new treatments for these other diseases as well, we hope. But it won't be quite as straightforward as sticking a bit of a virus into someone and hoping it works as a vaccine, if you know what I mean.
How are we doing in terms of neurodegenerative issues? You've touched on Alzheimer's. We're reading books about health span, vitality, lifespan. Dr. David Sinclair, what he's trying to do with the story he's trying to project. How are we doing on that? And how can we get a better grip of, you know, seeing our grandparents maybe not quite as we remember them? And that can be hard. How are we doing in that space?
Well, it's been difficult, David, obviously. I mean, you know, take Alzheimer's as a classic example. The many years of failed attempts to stop Alzheimer's. And then finally, this beta amyloid hypothesis comes up with this protein called beta amyloid is building up in the brain for some unknown reason, by the way, but that's the fact of the matter. It's seen in post-mortem samples. They make mice that overexpress it. They get Alzheimer's. Loads of evidence supports the beta amyloid hypothesis. And of course, companies wonder, can we suck up the beta amyloid? Can we clear it? And they use antibodies, one of the great parts of biology, you know. And they work a bit, and they weren't working that well. And then the whole hypothesis was being questioned. And then last week, a very clear study on a beta amyloid approach that did give benefits and slowed down cognitive decline in Alzheimer's. And in my opinion, it's the first real evidence that there may be progress now. So in other words, we're getting to grips with it to some extent. Of course, what that is about is understanding the underlying mechanism. You can't fix an engine unless you know which part is broken. And if the beta amyloid thing is correct, we'll see more progress. I see it, David, like fingertips on a cliff face territory. We're clinging on there. We may well see advances there. And with Parkinson's, it's a bit similar. There's a thing called alpha-synuclein that builds up in the substantia nigra. Again, if you clear that or get the immune system to clear it, that could be a way. So I think we're seeing advances in neurodegeneration from the immune side. Now, I would say that as an immunologist, but it is true. So we're seeing advances there, you know. Now, in terms of other things, the big question is what causes these diseases? We'd love to know that, because if you could discover the cause, that's the huge question to ask. And there's bound to be environmental influence, like head injuries are a big risk factor for these diseases, remember, as you know, as well, from sports injuries, all that. So there's stuff going on there that's interesting too. So let's put it this way. It's not for want of trying, though. These are devastating diseases. They will increase in incidence as our population ages, and we all know people with these diseases. So we need to really put our shoulder to the wheel and try to make more advances as soon as we can, because these are becoming so serious.
That's excellent. Just bringing into a bit more current affairs, we're coming into the winter periods and looking at incidents of infections and diseases. Is there anything we can do as a general population to maybe stave off bugs, stave off viruses at the moment? Should we look at maybe going back to masks, or what's your opinion on what we should do?
That's a tricky question, inevitably. Now, I think number one, and we all know this in space, the boosters are critical for this, because we're seeing waning of immunity, which is disappointing, by the way. Some vaccines last for 20 years, right? For example, the yellow fever vaccine gives you 30 years protection. Isn't that remarkable, with a single shot?
Wow.
This one, a dumb luck in a way, you know, we got lucky with the initial go, which is to stop severe disease. The trouble is they are waning, especially in older people. So number one, get the booster in, because there's great data from the US, and it lifts immunity right back up to 90% protection. So that's the first thing everybody should do who's eligible. Get your booster shot. Mm-hmm. Beyond that, I think the other thing we can do, and remember, it's no surprise there'll be an increase in the winter, because we're all back indoors. They're a respiratory ailment, so it'll spread like flu and so on in the winter. So how do we mitigate that? Stay home if you have symptoms. It's as simple as that. There's a risk you've got COVID. You might give it to someone who's vulnerable. Don't think of yourself as much as other people. So don't go out if you've got symptoms. The mask thing, it would make sense to wear masks in crowded settings, like on the Dart or in shops and so on. It's not a big ask, is it, to put the masks back on? So I reckon that should be recommended. Now, whether you mandate it, that's a political question. I wouldn't be able to answer that one. But I think my message at the moment is just think of others. I mean, we got through this together the first time round by most people following public health guidelines and becoming vaccinated. Same through this phase. Just think of other people is the main thing, really.
Great message.
I'd love to pivot to your book and the title. We actually were saying we actually really want to dig into that because obviously we've read it. But what does make us human, and what are you trying to share with that?
Well, we're so egocentric as a species, aren't we? That what makes me a very important thing.
Yeah.
Why is my species so wonderful? Even though we're destroying the planet, by the way. But forget that for a minute.
Forget climate for a minute.
Yeah, well, I'm a biologist, you see. So, and obviously, for a biologist, I'm obsessed with humans as much as anything else. And it always was intriguing to me personally. What makes us interesting, if you like, as a species? Like, why are we different from a bird or a dog or a dinosaur or whatever? And then, of course, we compare ourselves to other primates like chimpanzees, and there's loads of stuff over. I read a big inspiration for the book there was a book by Jared Diamond called The Third Chimpanzee, which I read about 20 years ago, which basically said if an alien came down to Earth, say 200,000 years ago, we were classified as the third species of chimp. Okay. So what's happened in that time is we got much more inventive, we got more curious. We begin to use tools more effectively. We begin to display art.
Started wearing hats.
Started wearing hats. That's exactly right. Yes, very importantly. Yeah. That's a picture of me. But no, the book tries to say, look, what makes us unique as a species is things like our sense of humor, or we love music, don't we? And our inventiveness. I mean, there's a chapter in the book on the great machines we've made, like the International Space Station, for example. And then there's a bit on robotics and how they might help us. We've been extremely interesting as a species in the past 100 years, but all the stuff we've invented. So I go into that a fair bit. But the main thing I'm trying to talk about is, what makes us interesting, I suppose, compared to other species is one of the overarching things.
Something you talk about as well in Immunology is food and our relationship with it. Interestingly, I love food, and I often joked about this, saying the hormones that cause my hunger levels to depreciate don't exist in my body. Leptin is absent from my body.
You're lucky, then, yeah. So you can have your cake and eat it.
Exactly, yeah. How much do what's gone on in kind of social media, kind of advertising, kind of marketing changed the hormonal probably secretion in our bodies in terms of our exposure to seeing these foods all the time, seeing more and more things in front of our face on screens all day, every day? It's
got to be a very important thing. And as you know, the big issue of the controversy of advertising fast food, I mean, that's been prominent, for years. Really. Yeah. Like, the way there were billboards outside schools from McDonald's, they stopped that. Because, because again, you're right, that could trigger a hormone, like ghrelin might go up, and ghrelin's the hunger hormone, as you might have read, or you may know already. So ghrelin goes up and that makes you hungry. There's no doubt seeing images might affect the ghrelin pathway, And I do think that chapter in particular, it's intrigued me when it was a guy called Steve O'Reilly, actually, was one of the first scientists, an Irish scientist in the UK in Cambridge, was the first to work on leptin and say, you're not obese because you're stuffing your face all the time. You're obese because there's hormonal changes that could be out of your control in your body. Mm-hmm. I don't think it's in that. My next book, I hate to mention it already, guys, I haven't finished it yet. There's the whole thing about fat shaming. That's a really horrible thing, And it's not just as simple. It's very complicated, this, you see. So I think, and again, to me, it's a great example of science discovering something new, in this case about obesity, that really helps us try to come to terms with this epidemic, And again, helps people who are prone to obesity in various ways, you see. So that hormonal connection, I think, is a really, really important advance in our understanding of obesity and metabolism.
Love to dip into the arts and creatives and the intersection of music and science, and kind of what is it about that? Because sometimes you hear, I'm into science, not into that sort of stuff. And then you go to them and they're not into that kind of thing. But what about those rare breeds of human that go across both worlds? And what's that like? Well,
it's a surprise there. Many scientists are musical. I'm not joking. It's not to quote the famous Tom Jones, it's not unusual for a scientist to be musical. And I play music, as you know, as a hobby myself. And I would often go to conferences, right? And this is over the years. And there'd be some kind of party at the end of the conference when everybody can network and meet up. And there'd normally be a band. And very often we get up and take the guitars off the musicians and start playing it. So it's a funny one. And then, like-minded people, scientifically and musically. So it's as I say, there's many different doctors and scientists who are musical. And they're not that far apart, because music actually is very structured. It's quite mathematical. The chord changes are systematic. So it's not that sort of a peculiar to read about musicians also being scientists, you see. And then for me personally, as a scientist, first and foremost, and then music is my big hobby, I had to dig into the science of music, didn't I? And what the science tell us about music. So I think it's a good example, isn't it? Yeah, of the interface between the arts and the sciences.
How does it make you feel when you're up in front of people and playing? What goes through your body when you're?
It's great. It's always fun. Let's start with that. Now, sometimes you might get a bum note, or maybe the audience aren't quite as responsive, but you're mainly doing it for me and my fellow musicians. We love being in a band together. There's a great sense of being part of a tribe or a team, that kind of thing. And in our band, there's 3 doctors and 2 scientists, you see. So we're very well qualified, But yeah, I mean, any musician will tell you if you play music and people enjoy it, it's a wonderful two-way street, isn't it? You're feeding off them and they're getting stuff from you. So it's always fun.
With tribes, you're mentioning there, your family, Margaret, Sam, and Stevie, scientists as well.
Yeah.
So at the Christmas dinner table in a house like that, what's the conversation like?
Well, the first thing we ask is, what is the nutrient value of turkey? We begin with that.
and
make sure you get a bit of roughage. Make sure you go for the sprouts, because otherwise there'll be a microbiota imbalance. No. Yeah, but it's funny that you would think we'd put them off. Because again, like parents often bang on about things, and the kids go, "I don't want that," and that might be evolved as well, by the way, to break away from the parents. But for some reason, both of our sons decided to become scientists at the moment anyway. So Stevie's doing a PhD in Cambridge in chemistry. Sam's doing physics in Trinity, doing nanoscience. So it's funny, isn't it? Yeah. So we do occasionally have scientific conversations around especially me and my wife, because she's a biochemist. And we often talk about our research, you see, when we come home after either a good or a bad day in the lab. We give each other advice and talk about our projects together, So it's very useful. And people have asked in the past, how could you possibly marry a scientist? Because surely you want to get away from it when you're away from work, But the trouble is that would have meant a whole part of my life would have been excluded from my partner, It's a bit like as if a German person marries an Italian and neither can speak to this language. That mightn't go very well. So I ultimately, I think I had to marry a scientist, given that such a big part of my life.
You said it earlier in the conversation there about, research, and it is the thing, data, understanding what we're doing. What is it about the research process that people can maybe understand a little bit more about? Because, if we're going to write a white paper, it can be daunting, it can be scary, research, having to look at papers. I don't think I can do that. That's for them. Yeah. How can we overcome that hurdle emotionally and actually understand that, well, actually, we need to be able to understand to look into science and research a little bit and take something.
It can be very difficult, because the trouble is we get more and more specialized, don't we? And then that really puts people off. What's the great phrase? More and more, but less and less. That's the history of science in a way. Yes. But the truth of it is, what attracted me to it from the very get-go was you'd say something, and it wasn't just an opinion. You data to back it up. So I'd show a graph and say, look, this is the way I think this particular thing is, and here's my data now. And you can choose to believe me or not if you wish, And I love this as well, the fact that the Royal Society, which is the world's most eminent, oldest scientific society, its motto is take nobody's word. Isn't that tremendous? Yeah. In other words, show me the data, because and it's not so much an arrogant thing or a thing to say up yours. It's satisfying, In other words, I can back up what I'm saying. Like, I really want to know X about the immune system. And it's all very well having ideas, and I can be happy with the ideas and the theory part. But if I do an experiment in a lab that supports that idea, that's tremendously satisfying intellectually. So that's why mark science out, of course, because it's a very empirical, sort of data-driven process. And for me, it's all about comfort. It might be one word I would use in a sense, because I've got comfort with my bottom line. And my bottom line can be supported by, and even better, David, when other labs repeat our work, that's a great moment for us, because there's always a risk of an artifact or something a mile of the machines being set wrong. If someone in Japan or America repeats our work, wow, we've discovered the truth. What we found is actually true. And for me, that's the primary motivation. It's not so much to discover a cure for disease X, even though that is the ultimate goal. It's just satisfying. It's kind of intellectually satisfying to see that. So if people are a bit anxious or fearful of it, remember, if you get through the data and you find data yourself in your own lab, that's a tremendous thrill. That's a wonderful feeling to have. Really.
One of your skills, I think, that you don't mind me saying, is that you are able to take complex systems, complex ideas, and distill them down so we aren't banging our heads together trying to understand. We get it straight away. Was this always a piece that you had, or how did you naturally harness that skill? Even the example of the leukocytes surfing the bloodstream earlier on in the conversation.
It was a gradual process, Ken. So it began with teaching. Absolutely. When I was appointed in Trinity, bloody 30 years ago now, they gave me, because nobody wanted it, the first 20 lectures for the first years in biology. Now, there's a challenge for you, because they're all 18, they're all sitting there, there's 300 of them, So now the good thing is, it's the first week of term, so they're quiet. And my job was to turn them onto biology. Now, many have, at the very start of the first lecture, I got, and many haven't done biology. A third of the hands go up, so you're talking to a new audience, So I had to learn how to convey mitochondria, or and you guys that would have done biology in your training, I'm sure, lyses. In other words, there are complex concepts in there. How do you convey it? And I was initially I might have made a hames of it. So you learn as you go along, kind of, and I loved it. I began to enjoy it more and more. And then next thing, I would often have to give a talk in public about my research. And again, you got to learn how to. And a big help to me, Kieran, was the science gallery. Remember that in Trinity? If you want to sign now, the sad thing is it's closed at the moment, but I got involved in that in 2009. They taught me how to pitch things for the public, because science gallery was all about outreach, And then eventually I ended up on the radio just because they asked me. I didn't volunteer. That was a challenge again, like a 5 or 10 minute spiel on something. You have to be really snappy, So I guess you learn on the job. In my case, I was able to learn as I went along. And it's years. What you see now is years of experience. It doesn't happen overnight. You got to learn. You can get tips. I mean, I would have learned a bit about what not to do. Like as soon as you put a jargon word in, the other person stops listening. Or if you have a jargon that you don't explain, they definitely stop listening. You've lost. So there's various things you can do to try to keep the person engaged. I guess there's tricks of the trade as well, which I would have learned along the way.
When did you recognize that science was for you? That it was the story of your life, because you identify yourself as a scientist there.
Yeah. It began. Looking back at it, I suppose it was a teacher. I must give credit to a school teacher called Fran Mooney. When I went from Bray, I went to Pres Bray, and he was our biology teacher. I thought it was brilliant what he was teaching me. I need more of that. So I began with it, and many of us would agree teachers can be hugely important in the direction we take. And I began to love biology. Now, why? I guess in our house growing up, my mother, when I was 11, gave me a chemistry set, which I quite like playing with. I loved watching David Attenborough, as I'm sure you two did as well. And Carl Sagan had a thing called Cosmos that blew me mind as a 15-year-old. So I must have been receptive to it in a way, But it was that teacher that really got me into it. And then I wanted to, and then as ever with things, when I was in sixth year, what are you going to do next? Do what you love. That was the advice we were given. And that was my favorite subject, biology. So I was naturally then driven into science in university, and I picked biology then as a subject. And then it was just a process then. Luckily enough, now I may have many people like that, and then after a year, they're sick of it and do something else. It was unrelenting for me then. Every year that went by, I got deeper and deeper in. Now, there were times of doubt, of course. And I almost left science a couple of times and other options and considered them, you see. But gradually I got drawn. The final thing, as I said earlier, was when I made my first discovery, I went, wow, this is the coolest thing ever, Like I've seen something no one in the world has ever seen before, And then it's true because other labs have repeated it, And that was during my PhD. So by then I was completely hooked. I couldn't escape it as a profession, really, as a result. And then the other thing to say, by the way, is, of course, to be a scientist is just to be curious. That's the most important trait you need, actually, about the world around you and whatever part of science you work on. Curiosity is the essence of it. But then if it's going to be useful to people, wow, that's a good add-on, And I've always been about trying to make discoveries relevant to these diseases that might improve insights for diagnosis or treatment, And the culmination of all that for me is in the last year or so, where our anti-inflammatory drug that treats inflammation was bought by Roche, the Swiss drug company, and they're running 4 trials in humans with our drug. We're waiting to hear back on those 4 trials as we speak. So now, of course, they could fail. Many drugs fall over. As you know, it's a challenging business to be in. But now I'm getting there, kind of thing. Now, can you imagine if one of those trials work, then I will go, wow, all that effort, it may actually yield a new medicine. Now, I have contributed with other companies, helping them along the way and stuff. So I've been part of the process of drug discovery. But these are my own drugs that I'm talking about, So we'll see if that pans out.
So thinking to your day to day, you're a very busy man, as you mentioned at the start. A lot of cognitive load across the day in the lab, looking at these, being on these calls. What do you do to unwind, maybe briefly, where you can't get away for an hour session on the guitar or a 30-minute session on the guitar?
You're in the nerve center here, by the way. This is my office, so this is me. I'm here every day doing all this sort of stuff. Oh, you got to get out and go for a walk occasionally. If I feel a bit tired or I'm thinking I'm not really making much progress here, I'll go down onto Pierce Street. There's a nice coffee shop. Get me fixed, back up again, that kind of thing, Or I might go and chat to a fellow scientist for a cup of coffee and have it. That can be very rejuvenating as well. But you're right, though, you need to take regular breaks because otherwise you just get bogged down a bit. And then and then turning off. It's very important to completely. I mean, I'm a great fan of doing nothing sometimes. Now, what doing nothing actually means is nothing with a purpose. We're so driven by purpose, aren't we, in our lives? I've got to tick off this list. I've got to have that meeting with that person. I've got to write that thing for the book or whatever. That's not what I'm talking about. I'm talking about stuff that maybe watch a movie or read a book or stuff that isn't actually purposeful. It's really important. And I guess as you both would know, that allows the brain to settle a bit. And now it begins to, it's like free association stuff. And that's when new ideas might bubble up. Or maybe have a bath. I'm a great fan, but of a long bath. If I'm away somewhere, I'll have a long bath in the hotel room. It's great, and I find that very relaxing as well. So it's essential, isn't it, that we can turn off? It must be said.
100%.
Nearly one of my last ones, and then over to you, Kieran. Curious, here's a scientist, a man who's doing loads of things, researching, looking at all those Bunsen burners, but you have a team there as well.
Yeah.
And what's it like in terms of, doing your own thing that you're curious about and engage with, and I want to answer those questions. The bit of the ego piece potentially, or just a curiosity piece. But then you've got your team, where you're building the energy and you're seeing them and interacting morning and afternoon. And what's that like? And I suppose getting the balance between the two.
The best analogy. I'm like a football manager now. I'm not playing on the pitch anymore. Okay. So behind me here, there's a football match going on in the lab. Not literally, but they're all doing their thing. They're the ones scoring the goals, and I'm the manager. I've recruited them. I set the tone, I set the area, I advise them on what to work on in a broad sense, and I give them a project, and off they go with their project, you see. And then they come and see me, and I'll give them advice along the way. Now, sometimes it's all them. The really bright ones don't need me at all, by the way, and they can do it without me. Some of them need more help here and there. Most people need encouragement of some kind and a bit of nudging and a bit of guidance. Where I really come into my own, I must say, is writing up the paper to be published, because I've got lots of experience how to pitch it, and then getting the referees to review it and all that kind of thing. I'm a great schmoozer. One reason I got a competence is you get the referees softened up to accept our so that's one of my jobs. And then, of course, my other big job is bringing in collaborators, because I can call anybody in the world now and ask them to help us. And then you need collaborators in this business, because they might have a different technique that we haven't got in my lab, some fancy piece of kit that we're missing. They might have ideas. I mean, the great thing is they're extremely collaborative. Like I tell the people in my lab, I'm not the boss. It's a team. We're all together in this. It's one big collaboration. And we both bring very important things to the table. They bring skill in the lab and doing experiments. And I bring a bit of support, a bit of guidance and ideas. And basically, one of my main jobs is I say to them, stop doing that, do this, for example. And that simply comes from experience, you see. So it's at its best when it's a collaboration. It should always be collaborative. And then the way the authorships on the papers go, as you might know, I'd be the senior author. They'll be the first author, because it's their work. And I'm like the last author, the kind of the overarching presence, I suppose, over the whole thing. But it's a really important thing to get right. And some labs get it wrong. The boss is too dictatorial. I'm a great fan of autonomy, actually, and especially in science. They've got to own their own work and own their own projects. Autonomy is a very important. Now, they need to be trained. It does take 3-4 years to get a PhD. Remember, my job is to train them. I'm a trainer. Again, the football analogy isn't bad. I'm on the training ground with them as well, helping them. So, and then eventually, some of them don't need much training. Some do. So it's a bit of a mix. It depends on the people themselves as well.
Great analogy, yeah. Thanks very much for all the information so far. We've one last question.
For the gaffer.
Thank you.
For the boss. For Pep Guardiola,
the manager.
Oh, that's a good comparison. Thanks very much.
Yeah, we're United fans, David and I.
We want to say Eric, but not yet, Eric.
Just not yet. Soon.
Not quite, yeah.
So the last question we've asked anyone and everyone who's come on the show, it's what does high performance mean to you?
High performance. Oh, that's a tricky one now. I suppose for me, what it means is achieving flow. There's an answer. In other words, the secret, in my opinion, overall, is if you're a musician or a scientist or whatever, if you get to this flow state, which means you're fully engaged, you're in the zone and you're delivering in a way, either with ideas or experiments or playing a piece of music, So high performance, you're performing at the highest level when you achieve that, as you know, this psychological term called flow state. And of course, remember, that's very beneficial for our health as well. If we can get into this flow state, it's one of the big dreams that we have, isn't it? Always to achieve flow. So for me, high performance is always about achieving that almost Zen-like calm when you're in the zone. That's what I would react to the term high performance.
Like you are today.
Well, now there you have it.
Professor Luke O'Neill, thanks for helping us understand, as well as everyone else, as to what makes us human and so much else, but also to echo what Kieran said earlier about making science fun, engaging, and easier to understand. And we do commend you for that, because it's such a skill, and we really admire you for it. So thanks again for your time. Really grateful that you've given us your morning, and we learned a lot. Just told our listeners.
Thanks very much, David. Thanks, Kieran. It was a great old chat.